Ganapathy, hi. Hello
Hello,
from
how are
Germany.
you? Namaste.
Namaste. I'm fine. And you? You're okay?
Getting younger day by day.
Same for me, you know. I think.
Of course,
Great.
Frank Clevens is younger than me, so.
Yeah. I know.
Is that true?
Yes.
Can you disclose your years of birth?
Well, I'm December 1950.
1950.
50?
Yeah.
44.
Yeah, that's why I said you are younger than me, sir. That is exactly why I said you are 6 years younger than me.
Me, 2010.
We all go back in that. Oh, yeah. Oh, you mean you from now on, we go back all the time?
We are going. Is that has that something to do with space? The further you go, the younger you become, or something like that?
Absolutely.
I think we should talk about that, and then people will be much more interested, you know, in this topic. Telling them you get younger when you're in space.
I definitely feel younger, much younger. Even thinking of space, I feel younger.
Yeah.
But that means if we fly east every day, you know, from Australia to the US every day. Every day we win one day, you know.
I offered myself as a volunteer, but Dr. Thais has not accepted it.
Really?
The simulation studies on Earth.
I will.
Senior citizen.
I feel that we can start.
Yes.
So this is the first webinar of our working group, Digital Health for Space and Remote and other extreme environments and remote places. So I'd like to invite Dr. Frank Livings just to give a welcome from the international side of Telemedicine e-Health, where this working group is part of. And then we start our webinar.
Well, thank you very much, Thais. And first of all, congratulations for organizing this webinar, which indeed is going to be the first of your relatively young and new working group, which is on medicine in space and extreme environments, which I think is a very hot topic in the whole field of digital health. Let's not forget that back in the 60s, which is what, 60 years ago already, that's when the real application of telemedicine saw, you know, it's beginning with space, and still is today. We can't imagine a space station or space flights at all without the use of telemedicine or telehealth, one way or the other. So again, thank you for organizing this, and I think it's going to be a very exciting topic, certainly with the speaker that we all know, Professor Ganapathy, which I also have had the honor to know for many years now, which indeed makes us younger every day. And I hope this, of course, is not going to be only the first one. It's going to be the first one of a long series. We do encourage or working groups to take those initiatives. You know, IsfTeH, the International Society, is there for its members. It's the members that make the society alive and keep it alive. And I think that's very important to know. So welcome to all. And I see we are already 16 at this point and 17 coming. So I'm sure there will be a lot of people following this. It will be recorded, as you know, and we'll be glad to post it also on the working group webpage so that you can still catch up with this. Again, good listening, and we listen to you, Professor Ganapathy.
Thank you very much, Dr. Frank Livings. It's a pleasure, you know, to have our first webinar of our group, of our working group of the International Society for Telemedicine e-Health. The working group official name is Digital Health for Space and Extreme Environments, as you mentioned. And it's my honor and my pleasure, in fact, to introduce the speaker of our first webinar, that will talk about technology in healthcare in 2030, a peep into the future. Professor Krishnan Ganapathy is a medical doctor with a vast experience in neurosurgery. He's also extremely dedicated to telemedicine. He is a pioneer in India in telemedicine. He's the director of the Apollo Telemedicine Network Foundation and Apollo TeleHealth Services. He also had a huge career in academia. So he was a distinguished professor at the Tamilnadu Dr. M.Ch Medical University. He's also an Emeritus Professor at National Academy of Medical Services, and he integrates some of the groups that I also work in. He's a member of the board of advisors of InnovaSpace UK, which is a British company, and he is, of course, part of this working group of the International Society for Telemedicine e-Health. Is the co-chair of this group, the Digital Health for Space and Extreme Environment. So everybody that has interest in specifically in this type of subject, please contact us, and you can be part of this group as you become a member of the academy of the society. So the idea is that Professor Ganapathy will have about 30-35 minutes to present his lecture, and then we start a discussion. So Dr. Ganapathy, the floor or the screen is yours. You just have to click on the first slide.
Sorry, there's some issue here. Can you see?
We can see the first, we can see several slides.
No, I know. Sorry, I don't know why I'm not getting it in full mode.
Just stop sharing and start again, maybe.
Okay, 1 sec.
Sometimes it happens.
Yeah, you're able to see it now?
Yes, we can see it very well and can hear you very well.
Okay, great. Okay. First of all, thank you, Professor Theis, and thank you, Frank Levens. I deem it a great privilege and an honor to give this introductory talk, and I'm looking forward to many, many more talks, more relevant perhaps to space medicine. Ladies and gentlemen, I'm going to put you on a time machine and take you with me on a journey which I'm absolutely sure most of you are actually going to witness. I have always been interested in futurology, which I think is a pseudoscience. It is a forecasting of the future on a systematic basis by extrapolating present-day cutting-edge technology. And this is what I plan to do in the next half an hour or so. As you can see, before I go into healthcare, let's spend a minute or two on how the world is going to be 8 years from now. There is going to be, of course, nobody expected the corona. The COVID is going to radically change the way the world is. But again, the major role played by Europe and the United States, it is foreseen, will take a back seat, and a new country, if you want to call it, a new region, not a country, called Chindia, that is China and India, are going to contribute to a major part of the world. Again, 3 of 8 billion people will have no drinking water. There will be climate changes. We're already seeing the global warming and things like that. 90% of restaurants will have some form of a 3D food printer. Whatever I'm telling you now is based on published material. I've reviewed the literature extensively, and this is all solid scientific data. Highways designated as driverless vehicles only is going to be a reality. India is very soon going to have an autonomous car, as per the announcement in the media. Again, 2 billion jobs are going to be replaced with new fledgling industries. The whole type of jobs we have now is going to be changed in just 10 years from now. One study says there are going to be more robots than workers in many industries. And again, digital payments is going to be the norm. I was shocked when in the last budget, the Finance Minister of India announced about taxation of digital assets. And I believe that in the next 10 to 15 years, paper currency as we know it today will probably disappear, at least in the developed world. Satellite networks are going to cover every centimeter, with private industries launching satellites by the thousands. This is what is going to happen, and it is going to be an unthinkable way of GPS. Business practices are going to shift completely. VR, AR, virtual reality, augmented reality, all this is going to simulate real life experience. Smart homes as we know them today are going to be replaced by smart hospitals, smart work. In fact, people are no longer going to work hard. There will probably be 4-day weeks, which is already starting. We are going to learn how to work smart. Personalized genomic medicine is going to be a reality. Now that I've given you a bare introduction, let's go into more scientific facts. This was a paper presented in the World Economic Forum, an interview of 800 technology executives and experts from all the continents. And this is the data which they showed just 3 years ago. Can you believe this? 10% of people wearing clothes connected to the internet. India already has got a staggering rural teledensity of 78%, and the urban teledensity in India is 123%. Wearable technology, we have several IITs and engineering colleges in India which have already started departments of intelligent textiles, and I believe that intelligent textiles is going to become a reality very soon. 5% of consumer products are going to be printed in 3D. Driverless cars will probably equal 10% of all cars, at least on US roads. The first transplant of a 3D printed liver, this will probably be printed in outer space. I'll come to this later. The first AI machine on a corporate board of directors. Now, this is information presented at the World Economic Forum. Now, I was shocked when I saw this newspaper cutting, which I have put on the right side. It is a venture capitalist who has funded $2 million to a group in IIT Madras to make what they call an e-plane. And they have announced that in 5 years from now, this is going to be launched in Chennai. Unfortunately, this video is not playing, or I would have shown you a video of the recent international festival in Dubai, where you can see with a Skypack, this gentleman is taking off. Manned drones, this is going to be a reality. And I believe that air taxis for individuals and for small groups of people, again, is going to be a reality. As an Indian, I'm absolutely delighted that the government of India, as early as 2017, appointed a high-power committee, and today we have white papers on a national strategy for artificial intelligence. And the use of AI, healthcare has been earmarked as one of the industries in India where AI is going to be used in a very big way. Now, if I'm just going to show you a few examples of what is called the Make in India. We no longer are talking of Make in India. We are talking of Make in India and Make for the world. We are able to do it at 10% of the international cost. I am on several committees of the Department of Biotechnology, Government of India, and I'm part of the committee which evaluates proposals for funding. And we are extremely delighted that many of these from the bench, they have come to the beds, to the bedside. On the right-hand side, you see a totally indigenous product manufactured for just $10,000, one-time capital expenditure, where in 120 seconds, you will be able to diagnose with a 99% sensitivity and specificity whether this newborn child has got a hearing impairment or not. In 2 years from now, this is going to be part of every child born in the country probably will be checked for hearing impairment. So like this, point of care diagnostics at 1/10 the cost. Today, a drop of blood, you can do 66 different tests. liver function tests, renal function tests, troponin 1, 2, etc. And I believe that the phlebotomy, as we call it today, putting a syringe needle, putting a needle inside a vein and drawing out blood will probably become obsolete. Biomarkers is another area. I would never have dreamt that in my life, I could be talking about diagnosing cerebral arteriovenous malformations in the brain by doing a urine examination. Yes, these are all still in the research stage, but what is research today will become a reality very soon. This was a slide which I got in 2012, and you can see as early as 2012, I literally had to search for the newborn baby, and that's why I put a marker there. This is how a newborn baby with multiple congenital problems was looked after in a neonatal intensive care unit 10 years ago. So you can imagine how the world is going to be in 2030. Non-invasive blood sugar monitoring. Unfortunately, the multinational companies, where we are talking of, it's $1 trillion industry, not $1 billion. There are a lot of obstacles in the way, but I'm sure that eventually glucometers as we know it will become obsolete. You no longer have to even prick somebody to get a drop of blood. You just wear a smartwatch, and this smartwatch will be measuring not only your blood sugar, but various other biomarkers, and through Bluetooth-enabled technology, sending it to the cloud. And with AI, we will be able to get dozens and dozens of biomarker parameters. 17 diseases are now being studied by the FDA as biomarkers in human breath, including COVID. It's a very advanced stage where a patient suspected to have COVID can just breathe in to a balloon-like device, and based on the exhaled carbon dioxide, you will be able to find out biomarker. You'll be able to make a diagnosis. Lung cancer, voice biomarkers. Can you imagine an AI program the way I am talking right now, and based on the quality of my voice, the timbre, the pitch, the intensity, the emotional components, everything can be broken down. And again, many pathological conditions will be able to be diagnosed by your voice alone. Neurologists traditionally have been diagnosing and treating, but in the future, we will have a new specialty called augmentative or restorative neurology, where one would actually could do an invasive procedure, deep brain stimulation, which today is being done for Parkinsonism and various other conditions. This could be used not just to treat obesity, but perhaps even to treat diabetes, hypertension, but more important, it may even make you more intelligent and smarter. Just a few weeks ago, a relative of mine in the US asked me, Ganapathy, have you been chipped? I honestly didn't understand. And then I realized that in Europe, and many of the listeners today are from Europe, so I'm sure you know much more about this than I know. I understand that several thousands of people in Europe have already got a chip implanted under the skin. Is again a question of time because before all of us or most of us become chipped, and we will be what is called a cyborg, a human cyborg. Brain-machine interface. The distinction between a brain and between what a machine can do is becoming less and less. Thought signals. Today, I'm using a wireless mouse. I'm using a wireless mouse to change the next slide. Today in the laboratory, it is possible for me to look at the icon, which is responsible for changing the next slide. And all I have to do is to wear a proper headgear. And believe me, that today the analytics, brainwave analytics have become so sophisticated that it is possible to extract my thought process. And if I just look at that icon, the next slide will come. This is already happening in laboratories. It's just a question of time before all this becomes commercial. Smart forks, smart chopsticks, food sensors, dietary chatbots, sensors on the table to test food for gluten, peanut, other allergies, etc. This happened last year. The world's first 5G-powered remote brain surgery For some strange reason, neurosurgeons all over the world seem to be interested in technology. And here again, this is a neurosurgeon who totally surgically operated on a patient with Parkinson's disease. The only difference was he was 3,000 kilometers away. Yes, at the moment, it still makes news. It is more for a journalistic, to hit the headlines. But if it can be done for one patient, it's just a question of time before it can be done for many, many more patients. 15 years ago, I told my bosses in Apollo Hospital that we should seriously think about pre-hospital management and how ambulances, we should have a telemedicine unit inside an ambulance hospital. Maybe I was too far ahead of the time, but I'm delighted that just 6 weeks ago, my colleagues in Hyderabad have just started this. Bharati Airtel is one of the world's largest mobile network operators, and Cisco, all of you are familiar with Cisco. So Cisco and Airtel have partnered with Apollo Hospitals, and the prototype, the first prototype is just being tried out in Hyderabad. You can see the interior of the ambulance, and this is what is going to happen. Telemetric devices to transmit the patient's health. 5G as a trial will be available by the end of this year. And in another 2 years, 5G should be available at least in urban and suburban areas. So this is what we are talking about. It's a reality. Again, the distinction between an electronic prosthesis and between my spinal cord, the brachial plexus, the peripheral nerves, and so on and so forth is becoming less. Several papers have been published in very well-known, respected journals like New England Journal of Medicine, Nature, etc. Just look at this, a neuroprosthesis for decoding speech in a paralyzed person who's unable to talk. Again, a paralyzed man in Australia tweets using his mind after having a microchip implanted in his brain. As I mentioned again and again, what is today in the laboratory will come to the bedside. Now let's spend a few minutes looking at the future of humanity. What is going to happen in healthcare? The way I look at it, there'll be a new, a hitherto unknown department, if you want to call it, called augmentative. This could be augmentative neurology, it could be augmentative cardiology, or whatever you want. Smarter, stronger, contact lenses taking videos, earbud which has a universal translator, exosuits which increase your physical strength, and particularly with space tourism happening with the effect of microgravity, there will be a commercial reason for all this. Brain microchips, a neural lace can be, it's a relatively simple surgical procedure to put on the surface of the brain, mind-controlled prosthesis. Today, we use RFID chips in all hospitals to physically locate the presence, not just of a wheelchair or a stretcher, but even the presence of a medicine or whatever you wanted. Supply chain management has taken a radical change in the last 2 years because of COVID. PPE, the personal equipment, personal protective equipment used in COVID, the way it was designed, the way it was tested, the way it was shipped, all this had used RFID chips, intelligent and smart RFID chips. So this is what is going to happen. Again, devices to control tremors. As a neurosurgeon, I have in my previous avatar operated on many times on patients with Parkinsonism. We used to make a lesion in the ventrolateral nucleus of the thalamus. Subsequently, we use deep brain stimulation. Now, the engineers are taking over, and the engineers are now being able to use externally fitted devices so that you need not tamper with the brain at all, and these devices can control tremors. No more cadavers. All over the world, it's becoming increasingly difficult to get thousands of cadavers in order to teach medical students the basics of anatomy. And I have seen some of these simulation on a big screen, and believe me, even though I learned it the old-fashioned way, believe me, you can learn much more of anatomy, physiology, pathology, pathophysiology, and so on with simulation. Again, the Apollo Hospitals has just started 2 state-of-the-art simulation labs, one in the north of India and Delhi, and one in Chennai. And we hope in the next couple of years, almost all medical colleges will be able to remotely access the state-of-the-art simulation lab which we have today. Procedures can be repeated again and again with no damage to the virtual body. Organs can be made transparent and modeled in emotion. Again, here we are talking of virtual treatment. The FDA has, today we have not SaaS, software as a service. We have a new connotation called medical device as a service. And the FDA has got a separate division today where they are evaluating products which will be used in the therapeutic armamentarium of a doctor based purely on software. Software as a medical device. Virtual reality treatment is already used for management of dementia, for chronic pain, and here you can see for identifying a vein and so on. It's impossible for any one of us to decide on the photo on the left, which is the God-given ear and which is the 3D printed ear. This is what is happening. Plastic surgery, prosthesis, all this is already started happening. The most interesting thing is this 3D printing is preliminary studies have shown that the results are far better when it is done in microgravity. I understand that there are two companies which already have trying to take the legal whatever is required. And I am told that the International Space Station, some of the experiments have been done on 3D printing. Robots have slowly started making an appearance in some of the hospitals in India. I'm not talking of the Da Vinci. I'm not talking of robotic surgery. I'm talking of robots which will help turn a patient. I'm talking of robots. In fact, in one hospital, the robot got the Best Employee of the Year award. So this is the new healthcare, what is going to happen. AI, artificial intelligence. There are at least several thousand papers published, and some of the Indian hospitals, including Apollo hospitals, we have tied up with Microsoft and with Google. We have just started clinical validation where looking at the fundus, we have developed a score where we try to evaluate the clinical risks of this patient developing a stroke subsequently. Diabetic retinopathy, semi-automated algorithms are now being used clinically. We have still not reached the stage where a retinal specialist is replaced, but I believe in my lifetime, this is actually going to happen. Smart drugs. I understand there is a pharmacologist in the audience, so I have to be very careful what I'm talking, but nevertheless, the poly pill, after you become 65 or 70 years old, as per the World Health Organization, most individuals have to take 8 to 10 medications every single day. In the future, we will have a customized, personalized, genetically determined based on your genome, a smart pill. So imagine a single pill which looks after diabetes, hypertension, convulsions, trigeminal neuralgia, you name it, your anemia, whatever it is. So this is the future. You're going to have a poly pill. Again, billions of dollars are being spent on trying to develop a pill which will postpone aging or prevent aging altogether. The whole concept, I mean, I belong to the BC era. I'm not talking of before Corona, I'm talking of before computers. I was the last neurosurgeon in India who was trained and qualified before there were computers in hospitals in the mid-70s and the late 70s. Today, using artificial intelligence enabled real-time non-invasive methods of near-infrared spectroscopy, you can see the lights on the smartphone. You are actually able to identify the genus and the species of an organism. These are in a very advanced stages of clinical trials, and I believe that patents will be issued very soon for products from India. So instead of taking a swab, instead of sending a smear for culture sensitivity, 48 hours, and particularly in rural India, you do not have microbiology laboratories. I believe that you will have a handheld device, and based on very sophisticated optics, based on the color which is reflected, you will not only be able to confirm that there is infection, you can even say what is the genus and the species. Capsule endoscopy, to my knowledge, there are at least 40, 50 gastrointestinal GE departments in India where they use capsule endoscopy. So instead of using endoscopy with an instrument, you just swallow this capsule and then it is isolated in your fecal matter, and then the whole thing is played again, and right from the mouth to the colon. Of course, there are differences. It may not be as good, but this is already started happening, and this is what is going to come. Robots drawing blood. This is very, very common, I'm told, in many of the Western countries. Again, drug response profile, pharmacogenomic profiling for drugs. Most of you know that it takes 10, even 15 years from the stage of conceptualization to making a drug actually available in the open market. In the future, already it has started. Today, the coronavirus, the vaccine is a classical example. The amount of ICT, information and communication technology, which went into the development of these vaccines is incredible. And now that we have done it for the corona, it's just a little more fine tuning is to be done, tweaking to make the same principle for other things. Future vaccines will not take 10, 15 years, but we should be able to do it very soon. IoT solutions for healthcare, Internet of medical things. There is not a single area in most of the bigger hospitals which are not which do not have IoT solutions. In the hospitals where I come from, this is very common. We have medication intake tracking, we have smart drug tracking, we have medical inventory, equipment tracking, and so on and so forth. These are only going to become more and more sophisticated. This is a report from McKinsey, one of the world's most respected companies. And you can see here, finding the future of care, the role of smart hospitals. I believe that the hospital as we know them today is going to become obsolete. Hospitals of the future will only be for procedures, will only be for polytrauma and not for diagnosis, not for medical treatment. A doctor in your pocket, a hospital in your pocket, a laboratory in your pocket. This is what is going to happen. Wearable bands, real-time tracking, self-aided examinations. You will even be doing your own ultrasound with the help of an electronic do-it-yourself guide, and you'll send the images to the cloud, and based on AI, they will give you a reasonable diagnosis. So this is what is going to happen. Who said that? I mean, I would never have passed even my undergraduate examinations if I had said that A group blood can be transfused to a B group person. Today that is done. Not only that, a pig's heart was successfully, the procedure at least was transplanted into a human. Of course, 8 weeks later, he died. But nevertheless, the very fact that he survived for 8 weeks shows that this is also a potential. And who knows, in the future, we may be able to have organs of various other animals with us. I wish to spend a few minutes on the metaverse. The doctor will see your avatar now. What is the metaverse? The metaverse is an augmented virtual world derived by convergence of virtual and physical space. Users interact within the augmented world, meeting each other virtually, immersing themselves in performing virtual activities under real experiences. We are not talking of augmented virtual reality or extended virtual reality. We are talking of what is called Web 3.0. We are talking of quantum computing, robotics, and so on. I mean, there's no time for me to go through all this, but the applications are endless. The world of extended reality in healthcare, you can see whether it is dentistry, anxiety mitigation, pain alleviation, or whatever it is can be done. Wearables, again, the microgravity, a major reason why wearables are going to increase is because you will be requiring this when you're several months beyond the Earth's gravity, and especially if the first trip to Mars is going to happen. I hope in my lifetime, I will see the first trip to Mars actually happening. So wearable technology I'll place a sure bet on the wearable technology. Virtual rehabilitation, tele-rehabilitation, you can see here almost $1 billion in a couple of years, and the COVID has ensured that virtual rehabilitation is a reality. I had already mentioned this earlier. These are all projects funded by the Government of India, Department of Biotechnology, which have come to a very advanced stage. Wound tissue oxygenation. So based on the color, based on the vascularity of an ulcer, we will be able to tell a plastic surgeon what exactly needs to be done intraoperatively, what is the depth to which you need to diagnose it, etc. Again, 500 industries in India have been involved in the launch of the Gaganyaan. Unfortunately, the coronavirus has set it back. And now, of course, the Ukraine-Russia war. As you know, this depends to a very large extent on the Russians, and I presume that there'll be a still more delay. But India's first space station, the Minister of State in charge of space, he announced 2 years ago that plans are already afoot for India to launch its first space station by 2030. And a Venus mission. India has already launched a mission to Mars successfully, and I understand that 2024 December, like Mars, Venus will also be a little closer to the Earth, and right now plans are afoot to launch India's first mission to Venus in just 2 years from now. Thanks to Dr. Theis and others, when I brought out this special supplement on extraterrestrial neurosciences, everybody laughed and ridiculed. We never thought, other than the authors themselves, anybody would read this. But today, 2 years later, we are extremely happy that several thousands of these papers, each of these papers have been downloaded several thousand times to show that there is a genuine interest in extraterrestrial clinical neurosciences. All of you are familiar with this, how a NASA astronaut's blood clot in space got treated by a doctor on Earth. This particular astronaut was doing an experiment, and when doing a Doppler on himself, to his horror, he found that he had developed jugular venous thrombosis. And I'm told that the drugs were actually sent to the ISS, and drugs were delivered to the ISS, and he was on this treatment for almost 3.5 months before he came back to Earth. I could go on and on, but I think I will stop in a couple of minutes. Just some healthcare from space down to Earth. This is always a question, particularly from a developing country and emerging economy like India, when we still have millions of people who are malnourished, when we have millions of people who probably still do not have adequate, good drinking water 24 hours a day. Are you justified in spending, even though ISRO's budget is 8% of NASA's budget, still are you justified? The answer is a vehement yes. And I have shown here many, many examples of direct examples of how space technology, entirely due to space science, they had their, because of that, we are able to have better mammograms, we are able to have point of care diagnostics, we are able to have better ultrasound, we are able to have capsule endoscopy, and so on and so forth. Ventricular assist device, a life-saving heart pump for patients awaiting heart transplants, was entirely because of the understanding of supercomputer simulation of fluid flow through rocket engines. Advances in treatment of osteoporosis and muscle wasting disease are all secondary to study of mechanical loading and tissue remodeling in a microgravity environment. Yes, the time taken is considerable, 5 years, 10 years, 15 years, but nevertheless, almost all the research studies which have been done in outer space have had some use or the other down on Earth. Smart watches measuring EEGs, wearables, we have already confirmed about this. Ultrasound, this I've seen videos of this. This is an amazing 4D, as you call it, ultrasound. Of course, in India, unfortunately, due to regulatory mechanisms, I do not think we will be allowed to use this, but unless the regulations change eventually. So this is, I mean, sometimes I wonder whether I am crazy or whether the authors who write this article are totally crazy. How could anyone spend so much of effort and time and write a very detailed article on digital health technologies to support human mission to Mars, knowing fully well that the chances of this actually happening is not that much, but then optimism is what we thrive on. Again, what is my take-home message? My take-home message would be that the distinction between engineering, technology, and medicine is becoming less and less. And I'm absolutely thrilled that 6 months ago, the Indian Institute of, the Indian Institute of Science, Bangalore, which has consistently been ranked in the top 50 universities of the world for the last 10 years, the Indian Institute of Science, Bangalore, has announced that it has got funding. They just laid the foundation. They'll be starting this in 2 years. And the IISc Bangalore will be the first university in India to offer a joint 7-year MD PhD program. Now, the Indian Institute of Science also has got a very powerful aerospace engineering department. The Indian Institute of Technology, Kharagpur, set up a school of medical science and technology 12 years ago. Next year, they're going to start their own hospital and start a basic MBBS undergraduate degree. IIT Kanpur is also starting a medical school. And I think this is the future. The future is that every medical doctor will have to know a good amount of technology and engineering. And similarly, you cannot be a professor of computer science or any branch of engineering unless you have had some grounding of how the human body works. So this merger between engineering, science, and technology, which has already happened in the US several decades ago, is starting in India. And I believe that this is going to radically change the way we are going to progress. The patient of tomorrow will be an e-patient, electronic, equipped, enabled, empowered, engaged, and unfortunately for white-haired people like me, an expert. Today, when a patient comes to me, he asks me much more questions than I was asked in my postgraduate examination, because thanks to Professor Google and Professor Facebook, he knows almost as much as I know, or a little more than what I know, so far as this particular condition is concerned. So dissemination of information is also going to raise standards. Gone are the days when the doctor could tell the patient, are you the doctor or am I the doctor? I am telling you so. Those days are all gone. Technology is going to be the future of healthcare. But as an old-fashioned doctor, I very strongly believe that technology is a means to achieve an end and not an end by itself. I shudder to think of the day when technology decides on what is to be done. I still believe that so far as a healthcare provider is concerned, his primary avocation is to provide TLC, tender loving care, wipe the tears of his patient, albeit virtually using technology, but you need to get into the mind of your patient, understand what your patient wants, and cater to the needs of the patient, not just remove a heart, put a new heart, or do something else. So I think this is very important, but at the same time, you have to understand that you can ignore reality, but you cannot ignore the consequences of ignoring reality. If Moses were to come down to earth again, 2022 years later, I'm sure all the 10 laws, the 10 commandments would start with the prefix, thou shalt digitally transform. Most of us are afraid of the future. We cling desperately to the present, not realizing that we have already become the past. The future is always ahead of schedule. And whatever I told you, I don't think you have to wait till 2030. I think is going to happen many, many years ahead of time. Thank you once again for allowing me this opportunity to share with you some of my thoughts.
Thank you very much, Dr. Ganapathy. It was a wonderful lecture as usual. I never get tired to listen to you. And I open to the floor or the screen to questions. You can type it on in the chat, or you can just turn on your camera and interact with us, which is much better, I believe. So I have a couple of one or two comments or questions, but I will let the audience to talk. So any questions or comments from the group? Don't be shy. Let's take the opportunity to discuss. Oh, Juliana from Brazil has a question. Juliana, welcome.
Thank you very much. Thank you very much, Dr. Ganapathy, for the wonderful lecture. I really enjoy it. And my question is in relation with the efforts that we're facing. Actually, you just presented lots of projects and lots of ideas. And in your opinion, are they going together somehow? For example, my background is on computer science, on biomedical software engineering, actually. And something that we are very worried about from the computer science point of view is that there are lots of differences, for example, related to the data format and to the data type for the interoperability of the systems and things like that. So the idea of using these kind of things together or even going the same way. So what's your opinion about that? So there are lots of efforts that are going different directions. Of course, we are considering that they are all related to the healthcare, but they are going different directions, or they are coming together and somehow with the idea of the collaboration or things like that. I'm not sure if I was clear in my question.
Thank you. That's a very interesting observation. I would take the middle path. I would say they are not converging. We are not converging, but neither are we diverging. So I think it's more or less parallel. One of the problems we have, I don't know, maybe I am biased, is the fact that the computer scientists, technologists, engineers, all of them, they do not have enough assistance from a medical doctor. See, I always say, providing healthcare is not like buying a pizza. It's not like buying a train ticket or a plane ticket. There are many, many more things involved. And it's almost impossible to reduce to plus minus, to reduce to algorithms, to reduce to mathematics, the emotions which a patient has. When I tell a patient he has a brain tumor, his response to the brain tumor, and as a doctor, I need to factor all that in before I offer the treatment. Unfortunately, you are smart, your algorithms, etc., they take into account the histology, they take into account every scientific fact, but I'm not sure they take into account what the patient wants. I mean, tomorrow if I get a brain tumor, I don't want any treatment. I'm very clear about it. So plus the economics, I may not be able to afford. So the computer says do this treatment without taking into account at all the availability of that treatment in the geographic area where the patient is coming from. The cost, is the patient covered by insurance? Does he have the money? Who's going to pay? What I'm trying to say is, so far as healthcare is concerned, I believe that it should never ever happen that a medical doctor is totally replaced. And of course, you have correctly mentioned there are so many concerns. But again, in India, we are not paranoid. I honestly think people in Western countries, no offense meant to anybody. Most of my relatives live in America. They're all US citizens, so I know what it is. India, we are still not paranoid about security. The word trust is still there. Maybe in 10 years, it will disappear. So whereas in Western countries, most of the people are paranoid about security, privacy. I mean, the way many of us think is, okay, so what, who the hell cares whether I'm a diabetic or a hypertensive? What does it matter if somebody knows what my HbA1c level is? So healthcare, we need trust. Without trust, you cannot deliver proper good healthcare. And I don't think you can reduce trust to a series of algorithms, to a series of mathematical equations and factor in. I don't think it's possible to give weightage. As an old-fashioned doctor, I may give 60% weightage to trust. The medical student of today may give 1% weightage to trust. This differs. You need to be culture sensitive. So unless you're culture sensitive, your algorithms you cannot have one size fits all. You cannot have you can diagnose diabetic retinopathy with an algorithm, yes, but the management of that diabetic retinopathy, in my opinion, cannot be Google or Facebook. It should be a human being who takes into account the various factors which are required.
Thank you very much.
Okay, thank you.
There are a couple of comments here in the chat, congratulating for your lecture. Marlise, João Castro, who else? Yusuf, I'm sorry if I'm not pronouncing it properly. Palit from India as well. So there is another question here. Anna from Germany, please. The floor or the screen is yours.
Yeah, thank you, Ganapathy. Thank you very much for that interesting lecture. Now, I have a technical question because I'm not a technician, I'm not a medical doctor, but I'm a coordinator of a 5G health project at our university in Germany. Now, when we think about using 5G in healthcare on Earth, it's very interesting. Yeah, we do in several use cases. I was interested when you said about the wounds. We are doing a use case of wound monitoring with augmented reality glasses. We will do some histopathology, slide scanning use case. And we also will have a drone and it will fly through 5G together with a defibrillator to a patient with a heart problem. Now, I wonder, how can we use that in space? Because now what I would like to know right now, okay, Mars is far away, but how is it on when we fly to the space or to the moon? What kind of connection, internet connection, or do we have I don't know, 3G, 4G, 5G? We don't have 5G, but what do we have? And from that on, we have to think about what can we do? Does anybody know what kind of connection we have on ISS, for example, or to ISS? I don't know it, but that would be very interesting to develop use cases and to do research on the technology which is available for to ISS, for example. Does anybody know?
I honestly wouldn't know the answer, excepting that I read a media report that I just forgot the name of the company, that they have established internet exclusively for the moon, on the moon. I don't know the technical details, but I do know that there was a media report which said there is a separate internet on the moon. Dr. FICS should be, or one of the space scientists here. I am a pseudo intruder, so I wouldn't really be able to answer your question.
So does anybody know, Thijs, for example?
Yeah,
whom can we ask? Whom can we ask at least? If we don't know it now, it's no problem, but that would be very interesting for us.
Yeah, no, for the communication now, it is basically what we use here on Earth. So it is satellite communication with the internet available for the ISS. And as Ganapathy was mentioning, and you were mentioning about Mars, one of the ideas for to speed up or to improve, let's say, the communication on these places is to create what we are creating now here on Earth, which is this constellation of small satellites. That would be for many things, not just communication necessarily, but also for to monitor the planet or the moon. So this is are the plans. One of the problems with that we also have here is the pollution of the orbit of of Earth. You are polluting it with thousands of satellites and litter, space garbage tools and satellites that don't work anymore and so on. So this is what we understand now. No, that's what we need, these satellites for communication. That's what is available, let's say. But I don't know. I'm a medical doctor, so I'm not in the area of technology. But I think that maybe in the future we can have different ways to improve communication or observation of Earth and other celestial bodies. Maybe not with these satellites, or something more, maybe smaller. I don't know. Like nowadays we had big satellites, and now we have this very small satellite, this constellation of satellite, which is kind of a new way of communication, of using this technology. So I think that Frank Livings has something to say. Or
Dr. Theis, there are 2 questions in the chat box. Can I answer them?
Yeah, sure. Please be my guest.
Okay, there's one question from Shivarana. Shivarana, thank you for that question. It says, I just want to ask that personalized genomic medicine will be very expensive, far away from normal personal demand. Will it be able to overcome prices in India? Okay, I can tell you at a personal experience about 8 or 9 years ago, when I was in active neurosurgical practice, I wanted some genetic tests to be done for some brain tumors. The cost was about 1,20,000, 120,000 rupees. That's about 15,000, almost $12,000. Last year, the same test, little more sophisticated now, little more reliable, sensitivity, specificity much higher, etc., etc. It had come down to about $150. It still is expensive, but I am very sure that the prices are going to come down. It is not going to be that expensive. And 3, the government is working very strongly on universal health coverage. In 5 years from now, as per the government's present plans, everybody is going to be covered, including the middle class, upper middle class, by paying a premium, etc. And when indicated, of course, you can't be doing a genomic analysis for 1.3 billion people, but when it is absolutely clinically indicated, I am 100% sure we do not have to send the sample outside India. It will be available somewhere in India. So that's the answer to your question. The other question about wearable technology emitting radiation, again, I am not a domain expert, but my general knowledge tells me no. When you walk in the sun, you need to understand that we are all exposed to radiation. There are certain parts of India, the southernmost part of India, Kanyakumari it is called. Australia, for example, skin cancer. Incidence of skin cancer is much higher in Australia because of radiation. So I don't think the wearable technology, the sensors which are embedded in your intelligent vest, the amount of radiation they produce, I think is negligible. Please, someone can correct me if I'm wrong, but radiation has never been described as one of the difficult factors in any paper I have read about wearable technology.
Okay, thank you very much. Frank Livings, please.
Thijs, I'd like to react on 2 points. First, the one that Anna just brought up, interoperability. I mean, connectivity is always going to be a major point. Ganapathy, you mentioned trust. Yes, we can trust, but I'm not sure we can trust connectivity. For sure. So it's based on technology, and we all know in any part of the world, all of a sudden electricity is no longer available for whatever reason, a storm, whatever, and there you go, and everything stops. We just need to be aware of that, and of course the technocrats on that will have to work very hard to make sure that it becomes almost 100% safe. Because everything is based on that. That's one comment. The other one, of course, I mean, yeah, I can understand, although my age, the vision that you have of the future, because that's what's going to be. no doubt about that. Certainly, if you read history since the beginning of the 20th century and since the end of the Second World War, things have moved so fast. Well, have moved on, but the way they've gone on recently, it's actually too fast. And that's what probably the human brain has a problem with, to deal with, that stand, to accommodate with it. So that's another sort of warning or concern that we need to have and be aware of. We can't stop it, but we must be aware of the backsides of everything. And that leads me, of course, to a conclusion where so much is going to depend on the evolution of the education process in the medical field, in the healthcare field. First of all, till recently, you have the medical schools at so many universities, and God knows if there are not thousands of universities around the world. And then the technology universities, and now all that has to work together. There's no telemedicine if it's only medicine or if it's only tele, but the two have to go together. And from what I understand, and again, I'm not a doctor myself, and even less a computer person, it may not be so easy for the computer people to really understand the healthcare approach and vice versa. So the need is the development within the frame of, as well, the medical schools and universities as the technology universities, to really start a total new brand of courses, which will be accommodating both from the beginning. Now, the good news on that is the young generation is already born with it in the sector. I mean, I'm still the one that works with or writes with a pen. But although, yes, I'm using a laptop and work like that, but the youngsters, they cannot even use the pen anymore. They use not only their fingers, only their thumbs, that, and at the written, that amazes me all the time. But so they have at least that advantage at the start, that they are familiar with that the technology. And that's what it will be continuously built on further. And I believe it will come to an end, but in the end, we are humans, and it's all about the humans, the patients, and we don't have to forget that. It seems so evident, of course, but there's a lot of work still to be done at that level. And I fully agree with what you said, Ganapathy, about the need, to feel what a patient feels. And I'm not sure that you can the machine will never do that. But one doesn't exclude the other. Thank God, the machine, now we can do things which, look, when I came out of university and I had to write my thesis, that was with a typewriter, not even electric, on stencils. And I'm not sure that a lot of you still know what stencils are or where. And we had to print it ourselves. And I wrote, I not only wrote that thesis, but I typed it and I stenciled it, and we had to go to a printer for the cover page, because it needs still to look nice. And graphics, we had to go to an architect office, to make blueprints of graphics. Can you imagine? That's 60 years ago. Now students can work on Word, can do presentations, use colors, whatever. So yes, it's good that we have advanced on that. But again, my conclusion on that is we won't stop the future. We don't want to stop the future, but we still need to master it. That's what you also said, Ganapathy. I think that's a very important element.
Thank you very much for your comments, Frank. Very well received. In terms of education, just a very, very brief comment of mine. That was one of the comments that I wanted to make. In fact, I think that we need to change the education of healthcare people, medical doctors and so on, because we need to know, we need as healthcare professionals to really understand the technology and the computer science and whatever, because otherwise we will be users only, and with more, let's say, limitations in how to apply to our daily life, treating patients and so on. And also will restrict our imagination of how to create new device or new technology, because as you don't have the basics, it is more complex. I have two more questions here, or comments. So first is, I'm sorry if I pronounce it wrong, Neja, is Neja?
Neya.
Neya, sorry, Neya. So
yeah, it's a very exciting lecture. Thank you so much. Also, my husband, who's an engineer, was listening before, but he had to leave. Anyway, me as a psychologist, I would wonder when you were speaking, Professor, about where the human ends and the machine begins. And, as much as I'm thrilled and all involved into the development of telemedicine and telehealth, and I'm there to speak for that, I also wish to turn everything off and go and live in the wilderness because it's a mind-blowing thing, as you said also, Frank, how fast this is developing and how we as people can adapt. And I think this is the only way, is to adapt and to master technology. And yeah, this is just my comment. And also I see that we have the colleagues from South America, and as India and China were mentioned in the discussion or in the lecture, that are advancing so much. I would just maybe ask, what is the place of South America here, if I may say, as South America, or I should refer to specific country. But this was just my thought, so where is South America, where is Europe in this, anyway, so just my thoughts. So thank you again for the lecture. And I want to say hi to Anna that we met in Dubai. I'm glad to also see you here, Anna Shawaz. So just wanted to say hi.
Yeah, hi. I thought, where did I meet her?
But my hair was nicer and my dress was nicer.
No. But I know your name and your face, and I thought, where did I meet?
Yes,
oh, that's really great to meet you here again.
Yeah.
And yeah, we should continue exchange, because just.
All right. Thank you for the time for my.
Yeah, thank you.
No, thank you very much, Ineia, for your comments, and also question about South America. I am from South America, but I don't live in Brazil right now. I left Brazil a couple of years ago, but I think that maybe the best person in this group to answer is the one that wants to ask a question as well, Professor Juliana, who is from the area of biomedical informatics and computer science, so she might have a better picture of Brazil or South America, and also can ask the question.
Okay, so, sorry, I was just, okay. Yeah, that's a difficult question, actually, but it seems to me, this is kind of my opinion, although it is part of my research projects, but that we have lots of advances here in Brazil, but they are really restricted to a small part of the population. Like we have, for example, the idea of using augmented reality, virtual reality, and telemedicine. Of course, it grew a lot during the pandemic period, but we still have lots of problems of having this kind of technology, or of the idea of this kind of technology being accessed by the people in general. So like the poor people, or people that they don't have the access to a very good health plan or something like that. So I have some pilot projects, for example, in the public health system that we have, that's called SUS. That's very good, actually. It's a kind of model. But even so, it seems to me, I don't know the opinion of Thais, that even living in London, but it seems to me that we still have lots of problems, access problems to this technological initiatives that we are having here. Yeah.
No, I basically agree with you. I think that we, in Brazil, no, and in South America, I think that in general terms, we have, in each country, there are many different countries. Let's say areas that are more developed, other areas that are more remote, and so with less, let's say, technological development. And so I think that it varies more, you know, in countries like Brazil or in regions like South America, Central America, than here in Europe that is more, I would say, more even distributed, you know, the education, technology, and so on. So it is still a bit behind, you know, some in this aspect to make it more even, the distribution of knowledge and technology and access to education and so on to be more better distributed, I'd say. But you have a question, Juliana?
Yeah, actually, it's a consideration because I liked very much the comment that Frank Levins did it before, and I was just thinking that the things that actually technology should be used and should be considered something to help medical doctors and help health professionals, of course, but especially on this kind of, for example, I would say boring activities or some activities that would not be able to be done by people, like, for example, analyzing lots of images and things like that. So the idea is to help the health professionals to be able to focus on really special and important things like giving attention to the patient, so talking to the patient. So maybe they would have more time to talk to the patient and to give this kind of attention. Yeah. So maybe this is something that could be part of our education to medical doctors and, of course, to the computer science people. Yeah. I teach here in an undergraduate course that's called Biomedical Informatics. Actually, we just have 3 universities in Brazil that offer this undergraduate course. And the students have some courses that are related to healthcare, to biology, and to computer science. So this is kind of an interdisciplinary course. Yeah. And something, of course, the technical aspects of it, I think that somehow they are being considered in general. Of course, we need that. I completely agree with the Professor Thais said before that health professionals should have more information about technological aspects of what's happening. Actually, I have a project that is starting now, IATA, is about that. And but in the same way, I think that this sociological aspect of the use of technological gadgets and initiatives should be considered. Yeah, I think that's it goes together with what Neia, I don't know if I'm pronouncing your name very well. Okay, Neia talked before that we should classify or understand a little bit more what kind of things are really related to people, could be done by technology, and actually use technology as partner of people. But of course, this is not automatically. This is something that should be planned. Yeah, we should have a kind of protocols considering this kind of thing, health protocols in general. Yeah. I don't know. I think I talked too much. I don't know if I was clear. So please help me, Thais.
Thank you very much. I just want to mention under this context that we are discussing now, the last slide of Dr. Ganapathy, that we cannot, we can deny or avoid reality, but we cannot deny the consequence of denying reality, you know. And I think that when we were discussing if the technology will somehow substitute the doctors, and if you look at the reality now, I think that if we are honest with each other, we know that it is happening already. If you go to a doctor, here in England and in Brazil, so I have this international experience of being a patient in different countries. It doesn't matter where you are, the doctors don't touch you anymore, they don't examine you anymore. They rely on the image exams, for example, or blood tests. And the image exam, they don't even look sometimes at the image exams, like X-rays or MRIs. They just look at the interpretation of that. And I have a very personal history, that my mother had a brain tumor. It was benign, it was a meningioma, and she had the surgery a year and a half ago about. And she very recently did the MRI of the brain. And the doctor looked at the MRI via internet because the result was available, and then WhatsApped her saying, everything is fine, you are cured. Now it's just rehabilitation, the final part of your rehabilitation, physiotherapy, and so on. So you can see that technology is really replacing doctors already. So you cannot deny that anymore. The consequence, I don't know, because it's still a bit new situation, but maybe with time, doctors and patients will have a completely different type of relationship. From my time, I feel so old saying it, from my time when I had patients in front of me and I had to examine the patients to have an idea of what was going on. So there are two comments here, Marlene.
Yeah, can I just, this very small comment in front, just considering what you said. I was just thinking that, is it a problem of the technology, or is it a problem of medical doctors that don't touch patients and don't maybe talk a little more to patients and give this kind of attention? Yeah,
I think that the doctors rely more on the, in inverted commas now, in the expertise of the exam than what they can extract by examining the patient or even listening to the patient. Sometimes it is very, it's not uncommon to quickly listen to the patient, order some exams, request some exams, and that was it. So it is happening, this tsunami is happening.
I think there is a third problem. I think there's a third problem in medical care. It is a patient who is responsible for this. At least in India, most patients in the cities of India are very unhappy and they're very angry if you do not do a CT scan. And they go, I never do a CT scan or an X-ray or anything unless I think the results of that investigation is going to alter the line of management. I hope you understand what I'm saying. With the extra information I get by doing a CT scan, I must change my course of management. So what does a patient do? He's very unhappy. He says, oh, big doctor, highly qualified doctor. He just looked at me, he touched me, he asked me the detail. You see, he never even asked for a CT scan. Then he goes to my student who gets a CT scan done, makes him spend $200, etc. And then the patient is very happy. Aha, the big doctor said no scan required. The younger doctor asked for a scan. Scan is absolutely normal, which is what I said. Yeah. So this is what happens, you see. The patients want the most sophisticated technology, even though it is not indicated at all.
Okay, so two more comments. I don't know who is first, in fact, because I was talking when you...
Marlise. Marlise was first.
Okay, so Marlise then.
Well, congratulations, first of all, to Professor Ganapathy for the fantastic lecture. It just was amazing. Thank you very much for giving us the opportunity to hear that, to know about it. And well, I like only to talk a little bit about my experience working with telepharmacy. And what I can see is the technology, and for me, it's like a tool, and this tool is very important. But actually, I agreed with Professor Ganapathy that the human is not going to be substitute. I think that is going to replace in some points when you talk about exams and diagnostic. But at the end of the day, what I can see when I talk to the patients, they really want to be care for someone, not for the machine. So it's very, in my opinion, the machine or the digital and all this technology is a very good tool, you know, to manage the patients and everything. But when someone is not feeling well or has a disease, you know, they really want to talk to someone. So the human contact is very important. Even that is not face-to-face, is using e-health, or I mean like a tele pharmacy or teleconsultant, you know, I think is very important. And my point of view is not going to happen, you know, it's not substitute. I think it's a very good tool. And I think this tool, the importance of this tool is growing, but it's not a substitute of the human contact. This is my opinion. That's it.
Okay, thank you very much.
Okay.
Anna?
I just want to say something very short. I like to hear that you say, okay, doctors don't touch anymore. Doctors use this device and doctors do this and that. I want you to consider, I'm from Germany, and I can tell you in Germany, it's completely different. We don't have any devices. Doctors don't use devices. Doctors don't want to use devices. That is the reality here.
No, that's very good.
That's all I wanted to say.
It changes from culture to culture, and even in a culture like Germany, that is a developed country full of with doctors, of course, and hospitals have access to technology very easily. They somehow refuse that. They still want
yes,
the
exactly.
The type of let's say in old medicine.
There are reasons, but that is too much now. Maybe what Ganapathy said, it's about trust. You know, in Germany, we do not really trust machines. We do not trust, we don't trust anybody. We don't trust vaccines. We don't trust, that's true. You know, we don't trust doctors. We don't want to get vaccinated. Sometimes it's not easy here, but it's interesting to talk about telemedicine in Germany. Is really interesting because you have to talk so much about it, and there are so many challenges, which is interesting also. I hope one day we will overcome all this, these obstacles. Okay, just my comment for that.
Very interesting, very interesting.
Thank you very much. No, it's quite, I think that Frank wants to say something as well.
Sorry.
You are muted.
Yeah, I just wanted to add that. It's funny. Actually, what Ganapathy just said about the patient, you know, not liking the fact that the doctor doesn't want to use a CT scan. So in other words, that patient trusts more the machine than the person.
Exactly.
You know,
absolutely.
And at the same time, some other people do not trust the machine. So again, it's going to be an evolution over time of our approach, and I say or as human beings, you know, to health. In my time, you know, you eat too much butter or not, it didn't matter so much. But nowadays, you read about all the things. Be careful about this because otherwise you get that. And you know, the funny thing is, my generation, when I in the 60s, somebody that was 60 years old was an old person, and the lifetime expectation at that time for men or women, whatever, was maximum 70. If you reach that, that was already quite an achievement. Nowadays, we don't even celebrate in Belgium, tiny little country of 11 million people. We don't celebrate people who get 100 years old. There are 2,500 of them in Belgium. So where before you had the reception at the municipality, nowadays, no, it's common. You have to reach at least 110 or 115. To hit the newspaper.
Just a quick comment. Here in England, if you turn 100, then you have you receive a letter from the Queen.
Yeah, well,
Really?
my mother got 100, and of course, I still have a photograph or a king and queen. Yeah, okay, that was the. But nowadays, again, that's over. What I mean is, it's a matter of evolution. And in the same way that, as I said before, the youngsters, you know, they are that. It's too late for me to get used to that ever, but it doesn't matter. And patients will also learn to live. I mean, look at all the ecological evolution that there is. The world gets conscious about the problems that there were. My generation wasn't conscious at all about that. And we have to accept that. And I said that comment before also, look, time is the only thing you cannot buy or sell, but you have to let time do its work, whatever time it takes. Look, the world turns, I will only get worried, and this may have related to the topic of today. I'm going to get worried really when the sun starts getting up in the west.
Yeah, well, I think that Professor Ganapathy showed something very interesting in his lecture, that is somehow easier to predict the future of technology than they predict the future of patients and doctors' interactions, what the psychology like Neha works with, because we can somehow predict the technology, we can see, or we can try to understand what's going to happen, the next steps of the technology. But so difficult to see these interactions, the social interactions, and this trust, you know, trust the machine or trust the doctor, trust both or trust neither of them. So it is quite an interesting debate. I think that it was an extremely successful webinar in the sense we learned a lot about technology applied, digital technology applied to health that could be used in space, in other remote environments, but also here on Earth in many scenarios, in academia, in hospitals. It is interesting that you have here people from Germany, Belgium, India, Brazil, Italy, Romania. I don't know if I'm missing any country. This is, I think that these interactions are very, very good, very healthy in the sense.
Maybe you should take a photograph, Dr. Theis, as you normally do. Yes. And I request everybody to switch on their videos.
Yeah, can everybody turn on the video so you can have a picture together?
You will take it, right, Dr. Theis?
I will take the picture. I'm not excellent in taking pictures like that, but I will try my best.
Oh, you are good.
There are a few more.
Yeah. Can you just turn on your... Don't be afraid of technology. Just turn on your camera.
Push a button.
Okay, maybe Anda is from Romania. A medical student from Romania. We know each other through the internet. Okay, so I will take the picture. 3, smiling, please. 3, 2, 1. Okay, let me see if we are all beautiful. If we are not all beautiful and in focus, I will take another one. I think that we are quite good.
Excellent.
Okay, thank you. Thank you, everybody. I think I have to leave now. Okay.
Congratulations again, Professor Ganapathy.
I hope to see you all soon.
Thank you so much.
Okay, thank you. I'll have to leave now.
Bye.
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 Thank you. Bye.